So you're going to have to break it up into some kind of and of course that would be tangent squared, correct? Antiderivative of tangent squared x times tangent squared of x dx. Now, using the Pythagorean identities, you know that tangent squared of x is equal to secant squared minus 1. And you know that because of the Pythagorean identities. Right here. So tangent squared is equal to secant squared minus 1, right there. Try to blow it up some more. Right here. So you use secant squared minus 1 in for one of the tangent squared. And the reason you do that is because you got to get some kind of secant tan, because you know that the antiderivative of, or the derivative of, the antiderivative of secant squared is equal to tangent. So you know there's some kind of relationship between secant and tangent. So that's why you want to put secant in there. So tangent squared x times secant squared x minus 1 dx. And now you can distribute the tangent squared. You get the antiderivative of tangent squared of x, secant squared of x dx, minus the antiderivative of tangent squared of x. And of course you can turn that tangent squared into secant squared minus 1 again. So you'll get tangent squared of x, secant squared of x dx, minus secant squared of x minus 1 dx. And then that's going to give you antiderivative of tangent squared of x, secant squared of x dx, minus the antiderivative of secant squared of x dx, minus the antiderivative of dx. Now finish it out, and you know that the antiderivative finish it out. Knowing that the antiderivative of the tangent, or the secant squared of x, is equal to the tangent. So your final answer is tangent cubed x over 3 minus the tangent of x minus, and the antiderivative of 1 dx, or is x, and that's your final answer. Be a plus. Because you distribute that negative right here.
Don't know if we did this one or not.
Excuse me. Antiderivative secant x over tangent squared of x dx. I would probably use my reciprocal identities on this one, because you can't do much with that secant of x except turn it into a reciprocal identity. Now the secant squared of x, it'd be different. So you can at least simplify it a little bit by using the reciprocal identities. antiderivative 1 over the cosine of x over sine squared of x over cosine squared of x dx. And like I said before, the reason that you don't use the secant tangent relationship is because that secant, you can't do anything with secant. Now, if it was secant squared of x, then you could do something. But it's not. Take a few minutes and work on that. Antiderivative of 1 over the cosine of x times cosine of x over sine squared of x dx, and that's going to give you antiderivative of the cosine of x over sine squared of x, and now you've got something to work with in the relationship between sine squared and cosine. Because you can bring that cosine squared, sine squared up, and it'd be sine to the negative 2 of x. And then you'd have u du. Or antiderivative of the cosine of x times the sine negative 2 of x dx. Now, of course, you can turn that around . Antiderivative of sine negative 2 of x dx, times the cosine of x dx and that's u du. So that would be sine to the -1 of x over -1. Bring the negative out. So negative sine to the -1 of x, or -1 over the sine of x plus c, and what's 1 over the sine of x? Cosecant. You could write it as negative cosecant. So I'll do it like this. So either one of those. I spent a little bit of time on this manipulation because it does help you tremendously to be able to manipulate using the identities, as well as just manipulating to get some kind of relationship, so you can take the antiderivative of something using u du or using some kind of relationship. So it does help you, especially when you're manipulating in Calc 3 and Diff EQ. The next section we go over, I think, is trig substitution. So we'll go over that next. I think that's 7.3. Look and see. Yeah, 7.3 is trig substitution. So let's move on to that. And if you have your book, it's on page 478. And I would say one of the most helpful section, I should have been showing it by now. I don't see it. They should give you the whole. They're not giving it to you. I thought they would give you this. Probably giving it to you afterwards. Let me see if I can find it. Usually they give it to you. No, they're not giving it to us. Okay. All righty. Let me just write it down for my notes then. They're giving it to you right here, but they're giving it to you in a lump clump. There we go. There's what I was looking for right there. Sorry. Got your sine, tangent, and your secant right here. And you need to know those three arrangements. You got your a squared, which is going to be your number minus your variable squared. You got your a squared plus x squared, and you got your x squared minus a squared. So you need to remember those and the relationship from there to sine, there to tan, and there to secant. So your best way to understand it is doing an example. So make sure you get that down. Pull it up so everybody can get it. And let's go with an example. Let's go with the antiderivative of 1 over square root of 4x squared plus 1 dx, or the antiderivative of dx over square root of 4x squared plus 1. Okay, so take a minute and work on that for a second and see if you can match it up and see if you can get it started. You know it's going to have some kind of relationship to secant and tangent. Why? Because it's a squared plus b squared, or a squared plus x squared, or x squared plus a squared. So, when you put it in this form, this tells you that you've got a triangle with 2x here and 1 here, and the square root of, what is it, 4x squared plus 1? How do you know that? I just threw it up there, why didn't I put the 1 over there where the 2x is? How did I know that? Okay. Nobody has any clue. Look at the box that I just showed you. So I told you to write it down. Where is it at one time? me find it. What does it say right here? It says x is equal to a tan of theta, Hubert. Thank you, class. So what's the tangent of theta equal to? Tangent of theta is equal to what?
Sine of theta over theta, or over cosine of theta.
If I wanted to get the tangent by itself, what would I do?
Divide by a.
Okay, so x over a is equal to the what?
Tangent.
Tangent of theta. And what is tangent? Oscar had a hunk
What?
of apple.
What? It's the opposite side of
Tangent
side.
equals what? Oscar had a hunk of apple. Opposite over adjacent. And that's where you get it. Y'all never heard of Oscar had a hunk of apple?
No.
Well, that's part of your problem right there. Who'd you have for trig? A piece of grass?
The Sokotoa thing.
Yeah.
Oh, Sokotoa.
Yeah.
Okay. If y'all Sokotoa people, then what is tangent? Toa. Whatever Toa is. Let me get like y'all. I don't know what Toa is. What is Toa? That's what y'all sounded like. Just quit then.
I'm gonna go live in the ditch.
Yes. Okay, for normal people that take trig, Oscar had a hunk of apple. So tangent equals Oscar over, opposite over adjacent. And the opposite is always across from the theta. And adjacent, you'll put a little man right here. His legs are always on the hypotenuse and the adjacent. So that's how we put the 2x over 1. Because in this little do-jigger right here, then right here, all right, is telling you that x is equal to a tan of theta. X is equal to a tan of theta by your rule. Okay, so solve for tan. So by the rule, the tan of theta is equal to x over what? What is our x? I'm sorry, x, 2x over 1. So by your rule, you have 2x over 1. By Sokotoa, what is 2x? The opposite. What is 1? The adjacent. And that's how you know. By the relationship between your x over a and your TOA. So now you got this. So the tangent of theta is equal to x over a. So with that, or the tangent of theta is equal to 2x. With that, you can find out what x is equal to, solve for x, and then find dx. Because if you have x, you can take the derivative of x. So what is x? We know that tangent of theta is equal to 2x, right? So what would x equal to? Tangent of theta is equal to 2x. 2x over 1. So divide by 2, divided by 2. X is equal to 1/2 tan of theta. Is that fair to say? So X is equal to 1/2 tan of theta. And if we have X, then we can get what? dx. Why do we need dx? We need to put something over this. We need to put something right there. So find dx of 1/2 tan of theta. What's the derivative of tan? Dang old secant squared, Hubert. That's right, class. Y'all about ready for that ditch, aren't you? Now, what's this section called? Trig what?
Substitution.
Trig substitution. So you got dx now. That dx can go where? Up top.
You left out the square.
Say again?
So you left out the square.
Oh, thank you. Okay, so now that 1/2 secant squared theta can go right there. Now you also know that the secant is equal to the square root of 4x squared over 1 over 1. How do you know that? Well,